In a groundbreaking mission to touch the Sun, NASA's Parker Solar Probe has made an astonishing discovery. Plunging into the Sun's atmosphere, the spacecraft has uncovered a mysterious source of solar wind. Ordinarily, the solar wind is a turbulent surge of energetic plasma once it moves away from the Sun. However, the Parker Solar Probe ventured closer than ever before, diving within a mere 13 million miles, 21 million kilometers, of the Sun's scorching surface. And there, it observed individual streams of particles being steered by magnetic fields as they emerged from massive holes in the Sun's surface. Solar wind consists of charged protons, electrons, and alpha particles, which can be categorized as either fast or slow. The fast solar wind originates from openings in the Sun's atmosphere and can reach peak speeds of 497 miles per second, 800 kilometers per second, twice as fast as the slow wind. Scientists have long sought to understand the reason behind this speed disparity between the two types of solar wind. Now, thanks to the audacious Parker Solar Probe, the answer may have been found. It appears that the faster flows result from sudden bursts of energy released during the rapid realignment of magnetic fields. The researchers' findings were published in the journal Nature on June 7. James Drake, a physics professor at the University of Maryland and co-author of the study, emphasized the importance of comprehending the Sun's wind mechanism for practical reasons on Earth. He noted that understanding how the Sun releases energy and drives geomagnetic storms, which pose a threat to communication networks, is vital. Given that strong solar winds can lead to geomagnetic storms capable of causing satellites to plummet to Earth and disrupting the Internet, scientists are eager to unravel their origins. Data from the Parker Solar Probe revealed that coronal holes, which are darker and cooler regions in the Sun's outer atmosphere, resemble showerheads composed of evenly spaced funnels of material spanning up to 18,000 miles, 29,000 kilometers, in width. These funnels can either loop back into the Sun or extend outwards, depending on the openness or closure of the magnetic field lines guiding them. Stuart Bale, a physics professor at the University of California, Berkeley and the lead author of the study, explained that the photosphere, the Sun's lowest atmospheric layer, is covered by convection cells similar to those in a boiling pot of water. The meeting and descent of these supergranulation cells drag the magnetic field into downward funnels, intensifying it due to compression. By measuring the speeds at which the fast solar wind flows, which sometimes exceeded 10 to 100 times the average speed, the researchers concluded that the only plausible mechanism for launching the fast solar wind is through magnetic switchbacks. Switchbacks occur when closed magnetic field loops near the Sun's surface connect to open field lines extending away from the Sun, resulting in a burst of energy akin to a whip crack as the field lines untangle and propel solar wind directly towards Earth. The researchers noted that newly formed switchbacks exhibit sharper kinks, causing solar material to be ejected at higher speeds compared to older, smoother switchbacks. Bale emphasized that the key finding is that the energy source of the fast solar wind comes from magnetic reconnection within these funnel structures rather than from the entire coronal hole. He explained that it originates from concentrated bundles of magnetic energy associated with the convection flows. To validate their findings, the researchers will continue to analyze data from the Parker Solar Probe as it progressively approaches the Sun, eventually reaching a final destination 4 million miles, 6.4 million kilometers, above its surface. At this point, the probe's instruments are expected to succumb to the intense heat of the Sun. Let us know your thoughts in the comments below and don't forget to subscribe to stay on top of the latest discoveries in science. Thanks for watching and we'll see you in the next video.